Question 7, part A. We're given this diagram. We're told Marcus is in charge of restoring an old theatre, but what we see is we see a semicircle and we see our rectangle. So just think of the shapes. Doesn't really matter what the story behind them is. So we're told that the perimeter is 80, and that is ER, not RE. We're told the perimeter is 80. Show that y is equal to 80 minus 2x minus pi x over 2. Okay, so what's the perimeter of this shape? We're only including 3 sides. So we've got 2x plus 2x plus y, 2x plus y plus y. And we also have the distance of the semicircle, which the distance of a circle is 2 pi r. So a semicircle must be 2 pi r over 2, which is just pi r. And our radius is x, half of the top. So plus pi times x. And we're told that that's equal to 80. So we just have to simplify down in terms of y. 2x plus 2y plus pi x is equal to 80. So 80 minus 2x minus pi x, you can see the answer appearing now, equals 2y. So y is equal to all of this over 2, which is what we were asked to show up here. So that's part A. In part 2, you're asked to hence show that the area, a meter squared, of the stage is given by a is equal to 80x minus 2 plus pi over 2 times x squared. So let's look, we just have a rectangle and a semicircle. Remember, circle will be pi r squared for area. So we have to get half of it. So we're looking at pi r squared over 2 for the semicircle. And for the rectangle, it's 2xy. And the reason they say hence, we've already got y up here. So area is equal to 2x times y. 2x times 80 minus 2x minus pi x over 2. Now the whole thing is over 2, so I'll just put that 2 over here because you can see they're going to cancel. And then we would have to add on pi r squared over 2, and r is equal to x, so pi x squared over 2. And if we simplify this down, I'm going to get the area is equal to x by all of these 3 in here. So 80x minus 2x squared minus pi x squared. Then we have plus pi x squared over 2. So these two things are like terms. We have a full pi x squared, but a minus 1, and then we have a half of 1. So we're going to end up with minus a half, so just this one with the sign changed. So the area will become 80x minus 2x squared minus pi x squared over 2. And let's look at the form that they wanted in. They wanted in this form here. So let's just bring the x squared outside. Doesn't matter whether it's on the right or the left. X squared, which would leave inside. Well, we want the pluses inside, so we have a minus x squared outside and 2 plus pi over 2 inside. And we have the 80x at the beginning. So you can see it's written in the same form. We just have the x squared in front of the bracket instead of after the bracket. So that's part 2. In part 3, we're asked to use calculus to find the value of x for which a is a stationary point or a turning point. A couple of ways to describe it. So let's look at a. We want a in relation to x. So we're going to differentiate a with respect to x. So let's just look and write a out first. I'm going to get rid of the bracket here. I think it might be easier. 80x minus 2x squared minus x squared times pi over 2. And that pi over 2 is a constant. So the 80x is equal to 80 minus 4x. You guys are brilliant at differentiating now. This becomes 4x. And if I just do this off to the side, if I put the constant in front, we should normally have it in front. The 2 is going to go in front, so we're going to again do 2 pi x over 2. And you can see that's just going to become pi x, but we have this minus sign, so minus pi x. And we know at our turning points, the derivative is equal to 0. So we're asked to solve for x here. So we'll bring the 2 x's over to the right hand side, but leave them on the left, if you know what I mean. 4x plus pi over x is equal to 80. And hopefully you've seen my error here. Just notice it. We had pi x here, and I rewrote it as pi over x, so it's pi x. So x times 4 plus pi is equal to 80. So it's a lesson I'm not going too quick. X is equal to 80 divided by 4 plus pi. And we're asked to find the value of x. So that's the value of x. We're asked to prove that the value of x you found in part, well, it said 2, but we know you can identify that it wasn't part 2. We found the area in part 2. Prove that the max value of x you found gives the maximum value of area. So to prove that it's the max value of area, we need to get the second derivative. We have the ADX here. We need to get the second derivative and show that it's negative. The ADX was 80 minus 4x minus pi x. So we can actually see this is going to be negative straight away. So the second derivative, d2a dx2, is equal to minus 4 minus pi, which we can see is less than 0. Therefore, max value or max area. Part 5, we're asked to calculate the max area. So we're just going to write that max area down again. You can see what we got here. 80x minus x squared times 2 plus pi over 2. So the area is equal to 80x minus x squared times 2 plus pi over 2. The value we got for x was here, 80 over 4 plus pi. Let's give myself a bit of room. So 80 times 80 over 4 plus pi. So this is just going to be calculator use. Minus 80 over 4 plus pi squared by 2 plus pi over 2. Using our calculator to get a value here, we're going to get a value of 448 to the nearest meter squared, 448 meters squared. Part B of this question, Marcus finds a leak in the roof and a bowl is put down to catch the water. When the depth of the water is h meters, the volume is 1 over 12 pi h squared by 3 minus 4h, and h is between 0 and 0.25. Find in terms of pi dv dh when h is 0.01. So we need to differentiate my volume with respect to height. Might be easier to multiply out the bracket first. So let's do that. So 3 times what's outside. So v is equal to 3 times 1 over 12 pi h squared minus 1 over 12 pi h squared by minus 4h. And I put the minus in twice just to don't make that mistake. So the volume is 3 over 12, so 1 over 4 pi h squared minus, and that's going to give a third, 4 over 12, 1 over 3 pi h cubed. So we differentiate this, dv dh is equal to 2 over 4, or 1 over 2 pi h, minus 3 over 3, which is just 1 pi h squared, and we're told that h is equal to 0.1. So putting this in, you're going to get 1 over 2 pi by 0.1 minus pi by 0.1 squared. And this will give pi over 25 as our answer. Part 2 of this question, water flows into the bowl at a rate of pi over 800 meters cubed per second. Now that is the v dt, the volume changing over time. Find the rate of change of h. Well, that's h changing over time. That's dh dt. And from previous we have dv dh. So let's create a chain rule question here. We're looking for dh dt. So there's a h and a v, but we want the h on top, so we want to say we would have to have dh dv, and hopefully this one dv dt. We'll get rid of the v's and leave us with dh dt. You can see here that the dv's will cancel. So if we fill this information in, dh dt will become the inverse of this one. So it was pi over 25, now it's going to become 25 over pi. And dv dt is pi over 800. So that's the HDT. And the pi's cancel. And we're left with 25 over 800. And there are 32 25s and 800. So that's going to be 1 over 32 for the HDT.